All right, this is the chi-square lab, and then you can click play, load those packages. We're still using the same data set that I always use, the GSS clean data. So we can click the play button and load in that same data set. And today we're going to be talking about chi-squared test. So chi-square tests can be used for two main things. One is to do a goodness of fit test, and that just works with one categorical variable. And the other one is tests for association, and that's the relationship between two categorical variables. And we're going to talk about both of them. Because the chi-square distribution is a distributional approximation. We have conditions we need to check. And in this case, what we need to check is that each of the expected counts is at least 5. So the first test that we're going to do is a test for goodness of fit. So that's just about one categorical variable, and we're going to consider the variable general happiness. So if I click over here, let's see, I think it's pretty far over. General happiness is things like pretty happy, very happy, and not too happy. So it has more than 2 categories. And so I'd like to test the following hypotheses: that the proportion of people who are not too happy is equal to the proportion who are pretty happy, which is equal to the proportion who are very happy, and that's 1/3. So it's 1/3, 1/3, 1/3, and the alternative is that at least one of the proportions is different. So we can start by looking at a summary of the data. So we could do a tally, and we could see it looks like these proportions are kind of different than 1/3 if I had to just kind of eyeball it, but we will do the test to see. But the first thing that we should check is, are the conditions for inference met? And in this case, I'm going to say we can assume so, because all the observed counts are so much greater than 5. So I'm not going to actually do the multiplication to find the expected counts, but the smallest observed count is 336, so I think all of the expected counts are going to be pretty big. And now we're going to use the chi-square.test function to do the test. So this function expects a tally, so I can just copy this one from up here and stick that into my chi-square.test. And by default, the chi-square.test is going to test that all the proportions are the same. If you had a different null hypothesis, you could specify the proportions you wanted to test, but for this one, we wanted to test if all the proportions were the same. So let's just write down a few things that we see here. Our test statistic is that x squared, or down at the bottom, it's the 615.74. The degrees of freedom are 2, and the p-value is approximately 0 because it's less than 2.2 e minus 16. So then the question is, what is the conclusion to the test? We reject the null hypothesis. We have evidence to suggest at least one of the proportions is different. So it's different than 1/3, but we don't know which one. So that was a goodness of fit test. We can also do a chi-square test for association, and this will tell us if there is an association between two categorical variables. So in this one, we're going to think about the relationship between the marital status variable and the general happiness variable. And our null hypothesis is there is no association between the two variables, and our alternative hypothesis is there is an association. And again, we should check that our conditions are met. So let's do a tally of marital status tilde general happiness, and let's see what that looks like. Okay, so again, I'm not going to do the expected numbers, but it looks like the smallest observed count was 15. So again, we will assume the conditions are met because the smallest observed count is 15, which is greater than 5. So again, we could use the chi-square.test function to do the test. And again, we're just going to wrap a tally, so I can copy that and stick it in here. I don't need to give it some null proportions because it's just going to test to see if there is an association. So let's hit the play button here. And we get a similar output. So again, let's see. The test statistic is that x squared 201.65. The degrees of freedom are 8, and the p-value is about 0 because it is less than 2.2 times e minus 16, 0.0000. Lots of zeros. It's basically 0. So what's the conclusion of this test? We reject the null. We have evidence to suggest there is an association between marital status and general happiness. So this is kind of like ANOVA. We can just see that some of the proportions are different. There is an association between the two, but we don't know what that association necessarily is. So that's chi-square tests. If you have questions, ask me during our synchronous Zoom session.